Okay, so fundamental theorem of calculus, still here. What is the antiderivative of the cosine of x? Sine of x, and we don't have to put the plus c. We can, if you like staying in that habit so you don't forget it. The only time you have to put it is if you don't have the numbers on your integral there, or bounds is what they're called. So now we plug in and we do sine of pi minus the sine of pi over 2, right? What is the sine of pi? 0 minus, what's the sine of pi over 2? 1. So we're going to get a negative answer here. Now, there's basically 3 categories of answers with this. When you're doing this, remember that you're actually still finding the area under the curve of these functions. You can get the actual area, and that happens if the whole curve is above the x-axis, or that whole piece of the curve. And we actually did that with this same problem, except we had different bounds. We went from negative pi over 2 to pi over 2. Because remember that your cosine curve starts here at a max and then hits 0 at pi over 2 and hits a min then out here at pi. And then comes back. That's your cosine curve. So at one point we found the area under the curve from negative pi over 2 to pi over 2, which is this area here. And that was all above the curve. So that's like this type. We get the actual area. The second type that you can come up with is the opposite of the area. And that's when the whole piece of the curve is all below the x-axis. Which is what we have here. Because we went from pi over 2 to pi. So we went from here to here. And see how all of that is beneath the curve? So we end up with a negative number, and if we wanted just a positive area, we would just have to change the sign. So if we've done all above, all below, what do you think that third category is going to be? Not always necessarily 0, but we're going to have pieces above and below. So these, we just say it's not the area. Pieces of curve. So that if you really wanted to find the area, you would have to do absolute value of each piece. So for example, if I did from pi to 2 pi, I would end up with 0 because they would balance out, but that is not the area. Now, I could also run my interval out here a little bit further. If I took this curve and brought it here and did all of that area, I would end up with a positive answer, but it would still not be equal to that total area because I'd have a little bit of negative taking off from it. Okay? Do you have questions on those? Because that was the main thing I needed to kind of clear up from Friday. Yes. Just wanting you to know, because test-wise, I could ask you to draw an illustration showing me a definite integral where you're finding the actual area, and you could just do what I did in blue there. Or I could ask you to show me an illustration of a definite integral where you are finding the opposite of the area. You know, I've got examples of all three on that same curve. So you have to show me, if you're drawing an illustration, you have to show me your bounds. You have to show me where A and B are. You know, you would draw this and then you would say A here, B here. And for the negative one, you would say A here and B here. Okay? Any questions there? Okay, let me get you a worksheet.